Welcome to lesson 3.1 on square roots and then how we can use that when applying formulas. First, we're going to make sure that we have some of the vocabulary so that we're all using the same vocabulary. And first is going to be perfect square. I think you all know what perfect squares are. They're the number that you get at the end when a whole number, that means something with no decimals, so whole number means no decimals, is multiplied by itself. So, for example, we know that 9 squared equals 81. 81, that's the perfect square, okay? That is the perfect square right there. It's the answer that you get after a number is times itself. Another way of knowing if a number is a perfect square, you can check. And if you take the square root of a perfect square, so when you square root a perfect square, there is no decimal in the answer. So if you're not sure if a number is a perfect square, you can always use your calculator, square root it, and see if there's a decimal. If there is, then it wasn't. But if it turns out to a nice number with no decimals, then it was a perfect square. Square roots, well, I've already hoped that you know what a square root is. Normally, we're just used to taking a square root on a calculator, but the definition is that a square root is a number that when it's multiplied by itself, and that it gets us the desired quantity. So if I say I've got 49 and I want to take the square root of it, then 7 is the square root of 49. So again, it's the answer that you get after you use the symbol. That is the square root. The other way of thinking about this, like the going backwards, is if we think that 7 is the square root of 49, then 7 multiplied by itself, it said right here. So if we take 7 and multiply it by itself, we do get 49. So 7 is the square root. So these perfect square is the answer, square root is the answer. Radical sign, that's the fancy word for what we probably would have called before the square root sign. But we're going to call it a radical. And now, if we evaluate these, I think it's going to be straightforward. We've already done 49. The square root of that is 7. The square root of 100, so we're thinking of a number times itself that equals 100. I think most of you know that it would be 10. But we also could use the calculator on it. Part I is showing us something. If we were to follow BEDMAS, the first thing we would do would be to square that 9, which would give us an 81, and then the square root of 81 gives us back a 9. But a short trick that we can do is we can recognize that the square root and a square cancel each other out as long as there's no plus or minus under the radical sign. So as long as no plus or minus under the square root sign. Okay, question 2 asks us to simplify root 4 times root 4. So the square root of 4, if we were to figure that out, is going to be 2 times the square root of 4 is another 2. And so if we do it the long way, we get that the answer to this would be 4. The shortcut in this one is when you have a square root times itself. So when you have something that's in a square root times the exact same square root, your answer is going to be whatever that guts of the square root was without the square root sign. So if we use that trick for number 9, square root 9 times square root 9 would just equal 9. But let's check and see. Square root of the first 9 would be 3. Square root of the second 9 is also 3. And 3 times 3 equals 9. So this trick is super useful. So in conclusion, if x is greater than 0, that means if it's positive, then the root of x times the root of x is just going to give us x. So that is a super useful rule. Oh, I don't know why I made it purple. Question 4. Question 4, root 7 times the root 7. So we're going to use that trick again. When we've got a square root and it's doubled times itself, the answer is just whatever the guts of the square root were. So in number 5, root pi times the root of pi is going to equal just pi. For 6, we're going to have to be a little bit careful. We've got 5 root 3 times 2 root 3. So I know I could do the 5 times the 2, and that would give me a 10. And then that leaves me with root 3 times root 3. Using our new trick, we know that root 3 times root 3 just equals 3. So we get 10 times 3, which is 30. Multiplying radicals. So the rule is that when two radicals are multiplied together, you multiply their radicand. So we got this big fancy word here, radicand. Radicand just means the guts of a square root. So the radicand is the guts. So if you have a square root and then these are the guts that are underneath it, then you've got the radical sign and the guts are the same as the radicand. Okay, so if we've got two radicals multiplied together, we multiply their radicands or their guts and put them under the same radical sign. So for example 1, root 3 times root 7 would be root 3 times 7, which would just be root 21. Question 2, we've got some multiplying going on, some stuff inside the square root and outside the square root sign. So we're going to do outside times outside, and I'll write that down. Outside times outside, and it stays outside. And then underneath the square root sign would be your inside times your inside. So outside times outside is going to give me 2 times minus 6, and then inside is going to be 5 times 7. So the answer would be minus 12 root 35. So when we practice this, root 5 times root 11, that's going to be root 5 times 11, which is root 55. For root 13 times negative 2 root 3, outside times outside means I'm going to do 4 times minus 2 outside, and inside my square root is going to be 13 times 3. So it's minus 8 times 39. One thing to note that I maybe should have said a little bit earlier, right here when you have them squished together like that, so when you've got the number outside squished up against the square root sign, those are multiplied together. So it's same like before, that squished together means multiply. Okay, number 5, in terms of outside, we only have a 7, so the 7 is going to stay outside. Oh, I was wrong. It's not just a 7. And a minus sign, which means it's a ghosty minus 1. So our outside is going to be minus 7. And then inside is going to be 19 times 3, which is 57. So we get minus 7 root 57. Okay, moving on. Radicals and powers of 2. In an equation, you can get rid of a power of 2 by square rooting both sides, so they undo each other. So if we want to solve for x in both of these, we would square root both sides. And when we do that, that means we're looking for a number times itself that equals 225. And if you use your calculator, you would get that 15 times 15 equals 225, but there's another possibility. And if we were in class, I'd make us sit and wait, and someone would eventually figure out that the other possibility is when you have minus 15 times minus 15. So when we square root solving for x squared, we're going to end up with two answers. We'll end up with x here, x equals 15, or x equals minus 15. And there's a fancy pants way of writing that. We can write it as x equals plus or minus. That's a new symbol, so plus or minus 15. Okay, for 8x squared equals 200. First thing we're going to do is make sure we get x squared by itself. So right now, x squared is being multiplied by 8, so I'm going to divide both sides by 8. And when I do that, I get that x squared equals 25. We want x by itself, so we're going to undo that square with a square root symbol. Remembering that when I do that, my answer is going to be both positive and negative 5. X squared equals 150. I'm going to square root both sides. So because I'm taking the square root of an x squared, I'm going to have my plus or minus. And when I do square root of 150 on a calculator, I get a decimal. So it's not great, and it goes on further, but I'm just going to write it to 2 decimal places. But the square root, the two values of x that would give x squared equals 150 are going to be both plus or minus 12.25. For the next one, x squared is being multiplied by 3, so we divide both sides by 3. That gives me that x squared equals 32. And then I want to get x by itself, so I undo that square with a square root. And on my calculator, when I do that, I remember that it's going to be plus or minus, and I get 5.66. So practicing, solving for x. X squared is being multiplied by 5, so the first thing I'm going to do is divide by 5. When I do that, I get x squared equals 25. Now I'm going to square root, take the square root of both sides. And when I do that, taking the square root of x squared, I'm going to get plus or minus, and the answer would be 5. For question 2, similarly, 3x squared equals 24. I'm going to divide both sides by 3 because I want x squared all by itself. So I get x squared equals 8. And when I take the square root of both sides, I'm going to get a plus or minus answer. So I get x equals plus or minus, and on calculator, the square root of 8 is 2.83. Question 3. 10x squared minus 7 equals 73. So we're going to have to do a little bit more algebra. I'm going to take this minus 7 and bring it to the other side. So I get 10x squared equals 73 plus 7, because when it changes sides, we go from subtracting to adding. So I get 10x squared equals 80. I want x squared by itself again, so this time divide both sides by 10. So x squared equals 8. Now I'm going to square root both sides. And we did this just in the last question. So x equals plus or minus 2.83. For question 4, I'm going to subtract, take this 3, bring it to the other side. So I get 4x squared equals 403 minus 3. So it equals 400. I still want x squared by itself. Divide both sides by 4. So I get x squared equals 100. I'm going to square root of 5. Take the square root of both sides. So I get x equals plus or minus, and the square root of 100 is 10. For question 5. Question 5 gives us that the area of a square is 5 centimeters squared. So the area of a square is 5 centimeters squared, and it wants us, here's what it wants us to find, give an exact value for the side of the square, which means we're going to solve for x. So in a square, we know that area equals length times width. But in this square, we know the area was 5, and we know that the length and the width were both x. So that means 5 equals x squared. We want x by itself, square root both sides. Because we're finding the square root of x squared, our answer is going to be plus or minus. In this case, it's 2.36. And for the first time, we're going to have to stop and think. So we have 2 possible answers for x. A positive 2.36 centimeters and then negative centimeters. But we can't have a negative distance. And so our only possible answer is the positive one, which means that therefore, this question was asked in words, so we'll answer it in words. Therefore, the square side is 2.36 centimeters because it told us centimeters here, and we got to be careful to remember units. Question 6. The area of a circle is 5 centimeters squared. Find the radius to 2 decimal places. Okay. So hopefully in your brain somewhere you will recognize that the area of a circle is pi times r squared. They told us that the area was 5. So I get 5 equals, now pi equals 3.14 times the radius squared. I want to solve for the radius. Find the radius. So I need to get r by itself. The first thing I'm going to do is divide both sides by 3.14. When I do that, I get 1.59 equals the radius squared. I want the radius on its own, so I'm going to square root both sides. When I do that, I get plus or minus 1.26 equals the radius. But same like before, we can't use the minus because that's not a real length, so it's only going to be the positive. So when I answer, I say the radius is 1.26, and the units were centimeters squared, so it's going to be centimeters again. All right, the next part of 3.1 is about adding and subtracting radicals. So when you have two radicals that have the same radicand, that means the same guts, right? Remember, radicand means guts. Radicand, remember this was your guts. The radicand is these guys under the square root. If they've got matching guts, then we can add or subtract their coefficients. So let's look. Example, I have 9 root 3's, and then I'm going to take away 5 root 3's. Both of the radicands match. So if I've got 9 of something and take away 5 of something, I'm going to be left with 4 of that something. In question 1, they give us 4 root 6's plus 8 root 6's. The guts match, so we can just add the coefficients. So 4 plus 8 is 12, and the guts stay the same. For the next one, minus 2 root 7's plus 5 root 7's. The guts match. Minus 2 plus 5 is 3 root 7. Question 3. I've got 8 root 5's minus 2 root 5's. The guts match, so it's 8 minus 2, which is 6 root 5. For question 4, we have 5 root 11 minus root 11. That really has a ghosty 1 in front of it there. So the guts match. So 5 minus 1 is 4 root 11. Question 5 tries to make it trickier, but you will not be tricked. I've got some stuff with root 7's. I've got some stuff with root 5's. I've got an invisible ghosty 1 in front of this guy here. First thing I'm going to do is look at the root 7's. So I've got 6 of those. Take away 1 of those. It's going to give me 5 of those root 7's. And then when I'm looking at the pink, make sure you look at, so I've got a minus 8 and a plus 3. So minus 8 plus 3 gives me minus 5 of those pink ones, which was root 5. So calculating the perimeter of this triangle down here means I'm going to add up all the sides. So the perimeter, the perimeter is 5 root 3's plus 3 root 3's plus another 4 root 3's. All the radicands match. So we can add the coefficients. So 5 plus 3 is 8 plus another 4 is 12 root 3. So the perimeter is 12 root 3 centimeters. Do not forget your units. Okay, we're still not quite done. Evaluating radicals that are not perfect squares. So often radicals do not contain perfect squares as their radicands. So same way we had bases in disguise, now we're going to have radicands in disguise. So lots of words there. We're going to go straight to this chart. If we want to simplify root 50, It says write the number under the radical as the largest perfect square possible multiplied by another number. So the first thing I'm going to do is I'm actually going to write out what all the perfect squares are. And you should probably have them written out somewhere up to 15. So 1 squared is 1, 2 squared is 4. Oh my goodness. 3 squared is 9, 4 squared is 16, 5 squared, 25, 6 squared, 36, 7 squared, 49, 8 squared, 64, 9 squared, 81, 10 squared is 100, 11 squared, 121, 12 squared, 144, 13 squared, 169, 160, 9, 14 squared is 196, and 15 squared is 225. So it's just good to have that written somewhere. So they want us to find, break down 50 so that one of its factors is a perfect square. So the way I do it is I go, okay, 50. 50 comes in between 64 and 49. So I'm going to check and see, does 49 divide into 50? Nope. Does 36 divide into 50? Nope. Does 25 divide into 50? Why, yes, it does. So I could write that root 50. I'm going to write it as 25 times 2. And then I'm going to use this new formula that says up here, I can break, because I can take the guts and multiply them together, I can also do the opposite, which is, oh, that was meant to be yellow. The opposite is this one here, so that if I have two things multiplied together under the same radical sign, I can split them into two separate numbers. So I'm going to take that root 25 times 2 and separate it into root 25 times root 2. But now, here's where the in disguise came in. I'm going to actually figure out that root 25 equals 5, and then root 2 stays root 2, so root 50 equals 5 root 2. So if we were to simplify root 200, I'm going to look for the perfect square that divides into 200, and hopefully you'll see that that's 100. So I could write it as 100 times 2. And then I'll take the step of writing it as root 100 times root 2. Remember, squish together means multiply. Then I'll square root 100 and get 10, and I'll leave the 2 behind. Square root of 162. So 162 equals, okay, let's look. So 162, I'm going to use a different color. 162 is going to be in between, oops, that was meant to be highlighter. In between these guys, 162. So 144 can't divide into 162. 121, nope. 100, nope. 81, yes. Okay, so 81 goes into root 162 2 times, which means I can write it as root 81 root 2 or 9 root 2. And then, trying to be tricky, but we know we're going to deal with each of these things on its own. So I'm going to figure out, write these as two different fractions. So it equals root 32 over 4 plus root 48 over 4. But we're going to see if we can simplify 32. So 32 happens to be 16 times 2. So I'm going to write 32 as root 16 times 2, and that's all over 4. So it's root 16 root 2 over 4, which is 4. The square root of 16 is 4 root 2 over 4. And I'm going to move this all up. I'm going to make it a little bit smaller because I ran out of room, because then I would like to simplify this and cancel the 4 with the 4, and I'm left with just root 2. And for root 48 over 4, I'm going to write smaller, so it's plus root 48 happens to have a 16 hiding in it as well, so I can write that as root 16 times 3. That's all over 4. So that's root 16 root 3 over 4, which is 4 root 3 over 4. And again, the 4's cancel, and I'm left with root 3. Now, plus root 2 and plus root 3, the radicands aren't alike. The guts don't match, so we can't do anything else with these. Question 4. So for question 4, and we've just got 3 more to go. Question 4, I've got 2 root 6 minus 2 root 24. This root 6 here is a hint. It's saying in the next radicand, there probably is a factor of 6 hiding in there. So let's see if that's true. I leave the 2 root 6 minus 2. Now if I divide 24 by 6, I get 4, and 4 just happens to be a perfect square. So since 4 happens to be a perfect square, I'm going to write this as 2 root 4 root 6. I'm going to take the square root of that 4. Now here's the new part. I had a 2 outside already. When 4 gets square rooted, it's now outside as well, and I'm going to write down that it's multiplied by that 2. Here was my original 2, and then here's the 2 that I got from the 4. So make sure that you keep whatever was outside, and when something comes out of the square root, it's now outside as well, and we're going to have to deal with multiplying those first. So minus 2 times 2 will give me a 4, and now the guts match. I have 2 root 6, take away 4 root 6, which gives me negative 2 root 6. Question 5. 3 root 54 minus 4 root 6. Okay, so again, the fact that there's root 6, first thing I'm going to do is try doing 54 divided by 6. I get 9, which happens to be a perfect square, so I'm happy about that. So I'm going to write 3 root 9 times 6 minus 4 root 6. So I'll break that down into 3 root 9 root 6. And if you want to skip right to this step without writing with the times in between, feel free to do that. I'm going to get rid of that highlighting. We're going to, oops, that was supposed to be pink. We're going to square root that. So I have my 3 that was out front, and then I'm going to take the square root of 3 and get 6. And that gives me 9 root 6. And all of these still had the minus 4 root 6 at the end. Now that we've done all this, the guts match, the radicands match. So I'm going to subtract the coefficients. So 9 root 6's, take away 4 root 6's, leaves me with 5 root 6's. Okay. I think this is the last question. Last question, yes. Okay. So we're going to take everything that we've learned and put it all together. I can see here I have a root 3. That's a big hint that somewhere in here, somewhere else, there's going to be another 3. And looking ahead, I see here this 27. I happen to know that 27 I could write as root 9 times 3, and 9 happens to be a perfect square. So I'll have negative 5 root 3. And then later on, I'm going to have, you know what? I'm going to rewrite this whole thing just so that we have the ones that I think are going to pair beside each other. So negative 5 root 3 plus root 27, because I was pretty sure they were going to go together. And then minus root 80 plus 2 root 45. We'll work on those in a sec. So negative 5 root 3, and we know that 27 is 9 times 3, and 9 happens to be a perfect square, which for these guys, if I keep going, don't worry, I haven't forgotten about the whole rest of it. I'm just leaving it for now. The 9 comes out, it turns into a 3. The square root of 9 is 3. We leave that root 3 underneath the radical sign. Now I've got it so that the guts match. They're both radicands of root 3. So I've got to add the coefficients. And negative 5 plus 3 is going to give me negative 2 root 3. Now let's go back to the other part of this question. Root 80 and 2 root 45. So my first thought is that I could write 45 as 9 times 5. and 9 would be a nice perfect square. So I wonder what happens if I do 80 divided by 5. When I do that on my calculator, I get 16, which is another nice perfect square. So watch this. We're going to write 80 as 16 times 5. So plus 2 root 9 times 5. So I can write that as root 16 root 5, which then when that 16 comes out side of this, when I take the square root of it, I'm left with 4. So I have minus 4 root 5. And then for the 9, I'm going to have another one. I'll write it right there. Plus 2 root 9 root 5. That's going to give me 2. When the root 9 comes out, it's going to become a 3. The square root of 9 is 3 times root 5. And even though the guts match here now, I still have to multiply 2 plus 3 to get my 6 root 5 first. So the first thing I did was I multiplied that, and I know I have a minus 4 root 5. So minus 4 root 5s plus 6 root 5s gives me plus 2 root 5s. And at the beginning, we still had the minus 2 root 3s. So if you watched all the way to the end, you've done a great job. Thanks for watching.